Hello students, in this session we are going to solve the sample paper that CBSE has released. It's the most recent sample paper and we are dealing with mathematics today. Okay, I'm going to solve sample papers for physics and other sciences as well, but today we're focusing on mathematics sample paper. Now this is the standard sample paper. Uh, if you note, there are two types of sample papers CBSE releases every year. One is the basic type and the other is the standard one which we have right in front of us. Okay, so it has 5 sections and we are going to start solving all the questions step by step, one after the other. Okay, let's get started. Let me first walk you through the general pattern of the question paper that you're going to see in your board exams. Okay, your board exam will have 5 sections, sections A, B, C, D, and E. Section A has all the multiple choice questions. In total, you'll have 20 multiple choice questions, 20 multiple choice questions, and every question will contain 1 mark each. Now, it's important to note that some of the questions will take a little bit more time, while the others would be, you'll just look at the question and you'll just mark the answer right away. It would be so easy. But overall, these 20 questions are going to take up a little bit of your time. Then in section B, you have 2 mark questions. You have 5 questions, okay? In section C, you have 6 questions of 3 marks each. In section D, you have 4 questions of 5 marks each. I mean, you can go through the question paper pattern and the general instructions. Go through this once on your own, okay? Okay, let's get started with the questions now. So here's our first question. There are 2 positive integers, a and b. They're given like this, where x and y are prime numbers. That's also given. We have to find out the result when we divide the product of a and b to the LCM of a and b. So what do we have to find out? Product of a and b upon LCM of a and b. Okay, so what's the product? The product is really simple. X cube y square multiplied by xy cube. So x cube y square into xy cube. This is our product. But what's the LCM? How do we find the LCM? See, a and b are written in terms of their prime factors, isn't it? It's given to us that x and y are prime numbers, so you can take a to be x into x into x into y into y, and you can take b to be x into y into y into y. Now, since x and y both are written in terms of product of their prime factors, we know how to find the LCM of this. LCM of a and b. Can you find out the LCM of a and b? Let's see what the LCM is going to be. It's going to be, so x has the power 3. So LCM is going to be x cube, and y, the maximum power is 3 again, so y cube. This is going to be our LCM. Okay, so let's write it down here. LCM is x cube y cube. X cube y cube. Let's solve this quickly. We're going to cancel x cube and x cube. Then we have y cube and y cube getting cancelled. We have y square x as our answer. Which option is this? Which option is this? Check this out. Y square x is also xy square. So it's option number B. So that's our answer. Okay. I hope this is clear. All right. Now we're going to look at the second question. Now the second question is really very easy. We don't have to work uh, too much to solve this question. So we have a polynomial y is equal to f of x. Now this is the graph of the polynomial. We can see that the graph cuts the x-axis at how many points? It cuts the x-axis at 1 point only. That means how many zeros does the polynomial f of x have? Just a single zero, okay? The number of places where a graph cuts the x-axis, that's the number of zeros that polynomial has. Okay, so only 1 0. So we can discard this, we can discard this. We know that there is 1 0. Now what is the value of that zero? What is the value of that root? Well, the value, we can see that. What value of x makes the value of y to be 0? The value is 3. So the 0 is this. Okay, and that's our answer, option B. I'll let you quickly revise the concept of a zero of a polynomial. What is the zero of a polynomial? It is that value of x which makes the value of y to be 0. A zero of a polynomial, if we consider the polynomial to be y or f of x, so the zero of f of x is that value of x which makes f of x equal to 0. You can go back and revise the way you've learned in schools. But yeah, this is the solution. Let's move on. Let's look at the third question now. So we have a pair of lines drawn on the graph paper. These pair of lines actually represent a pair of linear equations. A pair of linear equations. We can see from here that this distance remains constant, which means that these two lines are parallel, isn't it? These two lines are parallel. So we have parallel lines, this one and this one. These two are parallel lines. Okay, how did I conclude that? Because nowhere it's explicitly given that these two lines are parallel lines. So how did I conclude that? Because it says here that these two lines are never intersecting. Now if they are not intersecting, what does that mean? They'll go on parallel to each other. Okay, so if two lines are parallel to each other, are they ever going to cross? No, because they are not intersecting. If they are not intersecting, will they have a solution? Will they have a solution? No, they are not going to have a solution at all. So no solution. Now what's the condition for a pair of linear equations having no solutions at all? The condition is that the coefficients of x and y are in proportion, but the coefficient of the constant term are not in proportion. So a1 upon a2 must be equal to b1 upon b2. a1 upon a2 is equal to b1 upon b2, but it's not equal to c1 upon c2. If c1 upon c2 would have been equal to a1 upon a2 and b1 upon b2, that would mean that these two lines would represent the same line. These two equations will represent the same equation, isn't it? I'll explain. See, let's say if we have 2x plus 3y plus 1 equal to 0, and we have 4x plus 6y plus 2 equal to 0. Seemingly these two lines look like they are two different lines. And if you see that a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. We can see that, right? But these two lines are actually the same line. How? Let me show you. Let's work on this equation a little. Take 2 common from all the terms. So we'll have 2 into 2x plus 3y plus 2, plus 1. Let me delete this, yeah, plus 1. This is equal to 0. All right. Now you can cancel out this 2 from both the sides, because 0 into 2, it's 0. This is equal to 2x plus 3y plus 1 equal to 0. See, what did we get? We got exactly the first equation. So the first and the second equation, or the first and the second lines, are the same lines. That means in this case we will have infinite solutions. Okay, there are infinite number of points where these two lines are coinciding. All right, so this is our answer. Now I'm taking some time to explain all the aspects for these questions so that it's a quick revision for you all as well. Okay, so this is our answer for now. Let's move on to the next question. Okay, so let's come to the fourth question now. What do we have to find out? We have to figure out what is the nature of roots of this quadratic equation. To figure out the nature of roots, the thing we need to look at is the discriminant. I'm sure you all know what discriminant is. The discriminant value represented by d is actually equal to b square minus 4ac. What is b, what is a, what is c? I hope you all know that. Let me calculate the value of the discriminant. Discriminant is b square minus 4ac. Let me quickly revise what a, b, c are. So whenever we write a quadratic equation, 9x square minus 6x minus 2 is equal to 0. This is our quadratic equation for now. The coefficient of x square, that is a. The coefficient of x, that will be b. Remember, the coefficient of x is minus 6, this whole thing. And the coefficient of and the constant term is basically c. So this is minus 2. So once we know a, b and c, we can figure out the value of the discriminant. So let me pick the original color. Yeah. Okay. So discriminant is this. Let's calculate b square minus 6 square minus 4 times 9 times minus 2. You don't have to calculate this at all. You just need to see whether this discriminant is positive or negative or equal to 0. That's all. Now once you know that, you will know the nature of roots. So we have 36. This minus sign and this minus sign will combine to form plus sign, and you have some positive number here. If you want, you can calculate that. I don't need to calculate that. This is some positive number. So I can see that discriminant is, of course, greater than 0 in this case, isn't it? We can see that discriminant is coming out to be greater than 0. That means it's going to have two distinct roots. Two distinct roots for sure. Two distinct real roots is the answer. What happens if discriminant is equal to 0? If discriminant is equal to 0, then we would get equal real roots. If discriminant is less than 0, well, we are in a fix. There will be no real roots. We'll have complex roots. You are going to learn about complex roots in class 11 and so on. All right, let's look at the fifth question now. We have two arithmetic progressions and they have the same common difference. So if the common difference is same, I can use the same variable, and for now I'll use that variable, I'll use d. The first term of the first arithmetic progression is given, and that of the second arithmetic progression is also given. We have to find out the difference between their fourth terms. So first, you figure out what is the fourth term of the first arithmetic progression. A4 for the first AP, okay? First arithmetic progression. A4 is given as the first term, which is minus 1 plus n minus 1d, which is going to be 4 minus 1 times d. We've assumed d to be the common difference, right? So this is it. Let's figure that out. Minus 1 plus 3d. And we'll leave it at that. For the second arithmetic progression, again the fourth term would be, but this time you'll have to use minus 8, because for the second arithmetic progression the first term is minus 8. So minus 8 plus n minus 1, it's again fourth term. So this is minus 8 plus 3d. So we've found out the expression for the fourth term of both these arithmetic progressions. We have to find their difference. The question asks me to find the difference between their fourth terms. That means uh, this thing minus this thing. Now this is important. If you're figuring out the difference between the first and the second, it has to be 1 minus 2. So this one minus this one, which would be minus 1 plus 3d minus, so I'm calculating the difference now, minus the second expression, which is minus 8 plus 3d. If you expand this quickly, minus 1 plus 3d, minus of minus 8 is plus 8, and minus of plus 3d is minus 3d. This gets cancelled. Minus 1 plus 8, it's 7. Okay, just so you can take a look at this, this is 7. So we have found our answer. So we have found our answer, and it is option number C. Let's move on to the sixth question now. What is the ratio in which the line segment joining these 2 points is divided by x-axis? Interesting question. Let me roughly draw the axis so that we can visualize the points at least, okay? 2 comma minus 3, well, this is x-axis, this is y-axis. 2 comma minus 3, 1 2 3, 1 point would be here, this would be a 2 comma minus 3, and the other point is 5 comma 6, so 3 4 5. This is a rough diagram. It's not needed, like you do not need to do it in your exams. Of course, these are objective questions, so you don't need to do that. So yeah, 1 2 3 4 5 6. Okay, so somewhere around here would be the next point, and it comes like that. Okay, this is 0.5 comma 6. So this is our line, and the question is asking what is the ratio in which the line segment joining these 2 points is divided by the x-axis. Now if you take a look at the x-axis, this x-axis is cutting this line into some part, right? What can you tell me about this point? What are the coordinates of this point? Well, I'm not sure about the x coordinate, so I'll just write x. But y coordinate is definitely 0, isn't it? y coordinate is definitely 0. Let's say this point divides it in the ratio m1 is to m2. This point x comma 0 divides the line AB in the ratio m1 is to m2. I hope you all remember the segment formula. Using the segment formula, we can write that this y coordinate y would be m2y1 plus m1y2 upon m1 plus m2, where y1 is this one and y2 is this thing. Okay, use this and figure out the ratio m1 is to m2. That's what we are going to do next. So we have 0. Okay, let me move it like this so you all can see the question also. So 0 is equal to m2, I do not know, but I know y1. y1 is minus 3 plus m1 y2. y2 is this upon m1 plus m2. This goes to that side, gets multiplied with 0, becomes 0. So all we have is this minus 3m2 plus 6m1. This is 3m2 is equal to 6m1. What do we have is m1, or 3 upon 6 is what our m1 upon m2 is. That's what we had to find out. If you simplify it further, it's going to come out to be 1 upon 2. Do we have 1 upon 2? 1 upon 2? Yes, we do. 1 is to 2. That's the answer. Okay. So we are done with 6 questions. Let's move on to the 7th question now. A point xy is at a distance of 5 units from the origin. How many such points lie in the third quadrant? Now this is a question where you don't even have to touch your pen. There is a point which is at a distance of 5 units from the origin. Okay, let me help you visualize a little. This is our origin, 0 comma 0. How many such points lie in the third quadrant? This is our third quadrant. There is a point at 5 units. This is your x comma y. We are asking how many such points lie. Let me draw a few more points. Okay, one would be this, also 5 units. This would be also 5 units, and so on. So how many such points lie in the third quadrant? If you look at it, all the points lying on this quadrant of the circle would be 5 units away. And there are infinite points here. Infinite points. Okay, so there are infinite such points that lie at a distance of 5 units from the origin, and they lie in the third quadrant. So the answer is going to be infinite points. Okay, let's move on to question number 8 now. From the picture, from the diagram that's given, it's evident that it might be a question on similarity of triangles. But still, let's read the question once, okay? There is a triangle ABC. This is the bigger triangle. And DE is parallel to AB. DE is parallel to AB. What can you tell me about the triangle CDE and the triangle CAB? CAB and CDE. What can you tell me about these triangles? These triangles are similar. How? So there is this angle which is common to both the triangles, and these two angles are corresponding angles. Similarly, these two angles are also corresponding angles. So from AAA, angle, 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 similarity criteria, we can say that these two triangles are similar. Okay, if these two triangles are similar, we have a relation between their sides. Okay, the ratio of their side lengths is going to be proportional. We're going to use that property to find out the answer here. AB, DE, BE, these three sides are included, and also EC. What can I tell about the relation between AB, DE? So we can say that DE upon AB is equal to, since EC is involved, so I would say EC upon this entire side BC. EC upon BC. Now this is what is going to help us find the answer to this question, this relation. So what did we do? We have a diagram. In that there are two triangles. We established that those two triangles are similar. If they are similar, then their corresponding sides are going to be proportional. We've learned this property. Now we're going to use this expression that I've listed here to find out the value of x. Let's see if we can do that. DE upon AB is equal to EC upon BC. Think this through. DE is given to us x. AB is given to us as A. No problems here. EC is also directly given to us as C. What about BC though? What about BC? Let me show you the picture. BC is this entire thing. Well, EC, I know it's C, and BE, this part is equal to B. So BC, wouldn't it be B plus C? What do you think? Is it okay? Yes, it is. So we have this thing now, and we can quickly find out the value of x in terms of A, B, and C. This is our answer, which is option number. Okay, so let's move on to the next question now, which is question number 9. If O is the center of a circle and chord PQ makes an angle 50 degree with the tangent PR. So what is given to us is that this angle is 50 degrees at the point of contact, of course, which is P, and then the angle subtended by the chord at the center is also is what we have to find out. And we have to find out the angle subtended by the chord at the center. So we have to find out this blue angle, this one, because the chord PQ subtends that angle at the center. Okay, what are the things that we can find out now? These are the things that are given to us in the question, but what else can we figure out? PR is a tangent, OP is the radius of the circle. What is the angle between radius and the tangent of any circle? I'm asking what is the angle between OP and PR? Can you tell me? What is this angle? Angle OPR. So angle OPR is equal to 90 degrees. Okay, and now if I know angle OPR, can I find this angle? Angle OPQ. Can you find this angle? Angle OPQ is going to be 90 degrees minus 50 degrees, which is equal to 40 degrees. Okay, so I've found out angle OPQ, which is 40 degrees. Now tell me what would be this angle? Angle OQP. Angle OQP. What would be that angle? Look at the triangle OPQ. Isn't this an isosceles triangle? Because this length is same as this length. So this angle is also going to be same as this angle, which is 40 degrees. Now I know two angles of a triangle. Can't I find out the third angle of this triangle? The third angle is going to be, by the angle sum property of course, angle POQ is equal to 180 minus 40 degrees plus 40 degrees, that's 100 degrees, and that's option number B. That's your answer. Okay, so let's move on to the question. Let's move on to the next question. There's a quadrilateral PQRS. This is drawn to circumscribe a circle. That means this quadrilateral is touching this circle at these 4 points. This is a critical information. PQQRRS, the measures of these are given to us. We can see it in the picture. And we have to find out the length SP. Okay, we have to find out this length. What is this? Now, as soon as you see these two lines, what do you think? Do you know about any relation between these two lines? These are common tangents, aren't they? So, if I name this point as, let's say, A, this point as B, this point as C, this point as D in small letters, AQ and BQ, are they equal? Yes or no? Think on it. The part AQ and the part BQ, these are common tangents from a point onto the circle. These are equal. So I'll utilize this. This I'll assume as x, so this would also be x. So AQ is x and I've assumed BQ to be x. If AQ is x, what would be AP? What would be the value of AP? That means this length. It's, see, PQ is 12, so I can write it as 12 minus x. This is 12 minus x. If this is 12 minus x, this would also be 12 minus x. See, I'm getting sides because PS is what I have to find out, so I'll have to eventually go there. Alright, what is this part? Tell me. What is BR? BR. What is BR? It's 15 minus x. If BR is 15 minus x, CR is also 15 minus x. Now comes the important part. What is, okay, I'll just enlarge it so that you all can see a little clearly. Okay. Now, what is, this is the critical part now, so I'll use a different color. This part, CS, it's 14 minus this, isn't it? It's 14 minus 15 minus x, which is equal to x minus 1. You can calculate this, it's not that difficult. It's x minus 1. If this is x minus 1, What can we say about ds? ds is also x minus 1. Okay, ds is also x minus 1. So we have the length of ps now. How? We just add the value pd and ds. So that's what we had to find out. Okay. Um, yeah. So SP is equal to 12 minus x plus x minus 1, which is 12 minus 1, which is 11. So the answer is option D, 11 centimeters. Now, this all might seem a little complicated, little too time taking, but you've already proved a result like this before. So whenever we have a circumscribing quadrilateral, we can say PQ plus SR is same as QR plus PS. You can use this relation as well to find out the answer directly. Okay, but I told you the method where you don't need to remember this result. Okay, all you need to remember is that this line is same as the length of these two lines are the same. So even if you remember this part, you'll be able to solve the question pretty easily. All right, students, we're going to take a break before we move on to the next question. Take a 5 minutes break and then come back.